All right, good morning or good afternoon, everyone. Welcome to APNIC eLearning web class. This is the second session that we are having for today. It's the 8th of July in 2015. It's 1 o'clock in the afternoon from Brisbane, Australia, where I'm doing this class. Now, the topic that we are going to cover is on network security. Now, I know network security is a very huge topic. It's actually really hard for us to choose which ones to discuss. But for this one, we will focus on the fundamental concepts that we have to be aware of when we deal with security. Now, before we go into the details of that, I also would like to introduce myself very briefly. My name is Cheryl Hermoso. I work for APNIC as a training officer. I'm part of the training team, and we do conduct workshops face-to-face. We do tutorials and also e-learning sessions like this on topics that are important to the internet community. So we do network security. We also do IP, IPv4, IPv6, Internet Resource Management, DNS and DNSSEC, as well as BGP and routing. So if you're interested in any of those topics, please feel free to access our website, training.apnic.net, and look for the sessions that you're interested in to register. Now for this session, it will run for 1 hour. So at the end of the session, I'll be asking you to fill in a survey. I'll post the link towards the end, and I hope that you will please fill that in. Okay, so what are we going to cover? Now, again, this is a fundamentals um, e-learning. So we would basically want to cover as much information as needed before we go to details on implementation. Okay, this will be our foundation, our background, so that when we start implementing different technologies, different protocols, we kind of have an idea, or we know the foundations behind it. We know which ones we needed to protect and things like that. So we will look at the goals of information security. We will look at different attacks that are happening. And to be able to do that, we will look at the different layers of the TCP/IP protocol stack. We will have some examples. We will look at how we can add protection on top of it. So we'll look at trusted networks and access control, cryptography and public key infrastructure, VPN and IPSec, and a little bit of the APNIC Whois database and how we can use it when it comes to security. Okay, it's not going to go through details of IPSec and details of PKI and cryptography, but just enough information because we have limited 1 hour session for this. Let's begin with the goals of information security. Now, a lot of us probably are aware of this. Okay, very simple information, very simple topics, but this kind of identifies, okay, the type of protection that we are going to implement later on. So our goal is basically to protect our data. It can also be to protect the person, okay, the identity of the person, or the machines that are sending, data or packets from different machines and the processes that are running. So we have these kinds of goals, but essentially it's about protecting our data, right? So information security is concerned with protecting this data, and the best way to achieve it is to look at these three core principles of network security: confidentiality, integrity, and availability. Some of you have heard about this. CIA triad is what we normally would call it. So what are they? Confidentiality obviously is about preventing unauthorized use or disclosure of information. If you have information that can only be read by a handful of people, you want it to be kept that way. There shouldn't be a way for someone that is just listening on what's going on, what transactions are going on in the wires. It should be impossible for them to read the messages that you have sent. So that's what we mean by confidentiality here. It ensures that your information cannot be exactly accessed just by anyone without any proper authentication and authorization. Okay, this means that you have some form of access control. If we're transferring data, confidentiality also means that we are providing assurance that this information can only be read by the intended recipient, but not anyone that is maybe um, reading through an intercepted message. Okay, that's confidentiality. Integrity refers to the accuracy and completeness of your information. So when you receive something, maybe it's a message from your boss, how sure are you that the contents of that message is correct, it's accurate, and no one was able to tamper with that content. That's what we mean here by integrity. The data that you received must be the same, exactly the same information that was sent, and it has not been modified otherwise. It means that data has not been altered while it is in transit, either in an intentional way, like someone um, really got that information, changed it before resending it, or maybe in a unintentional way, like some problems with the network, so some packets are dropping, so the message that you receive is corrupted. Okay, that's also affecting integrity of your data. The other one, and the last of these three, is your availability. Okay, it ensures the reliable and timely access of your information when and where you need it. For most of us that are providing services to our customers, whether it's maybe network, uplinks, transit, or web services, then we want to make sure that these services are available to our customers as much as possible 100% of the time, right? But we know that's not possible. So we try our best to keep it up, and if something happens, find a way to solve that problem easily so it will be available sooner. So that's CIA. Confidentiality, integrity, and availability. These are the three core, I would say, principles of security that would be our foundations. And we have to keep this in mind as we meet different protocols and implementations. You have to think, what of these goals am I trying to protect? If I do this, if I implement this, okay, what am I protecting? Is it data? Is it the confidentiality of the data? Is it integrity? Is it availability? Okay, something that you always keep at the back of your head when you're doing these implementations. So question is, why do we need security? I think this is pretty straightforward, and we all know the answer to that. The internet is not a safe place. It used to be when only a handful of networks are connected to it. So there is trust implied. It's still like that right now, right? There is really big trust implied. So we implement more security protocols on top of the security TCP/IP protocol stack to add those security measures. What sort of information are we trying to protect? Data, okay, maybe it's information about our company, information about our business, those intellectual property rights that you want to be kept just within your business. It can be about protecting identity. Is someone trying to impersonate you? Or maybe the resources that you have, credit card details, access to your emails, access to your medical or different types of records. So we want to protect them as much as we can. And obviously, we all work in the internet age where we need to connect with the internet with everything that we do, whether it's personal or business. Okay, we provide online services. We do our communications and our business through the internet. So it's just imperative. Okay, I don't think there's any question why we would really need security. It's a must. But how are we going to do that? Now, first, I would like us to look at these different layers of the TCP/IP protocol stack. And the left side, you also have the OSI reference model, because as we probably have heard of, you are only as secure as your weakest link. Okay, and you see here that there are different layers to how your data is being sent, different ways that it is processed. Okay, so we have to provide protection in all of them. Let's just say that most of us would be using HTTPS. Yes, okay, I'm using HTTPS. My data is um, secure. But what about the internet layer? Okay, what about the part where it is broken down into packets, into pieces before it is being transmitted. What sort of protection are you adding there? Are you actually sending that? Although it's safe, it's secured, um, secure HTTP. You're using SSL for that, but are you actually sending to the correct neighbors? Okay, things that you would worry about in the network layer may not be existent when you only think of securing the upper layers. Okay, so the best way is to look at them from different perspectives. Here you can see all the different protocols that are implemented on different layers. Okay, we're mostly using the OSI reference model here, although we have the TCP IP, which is the more accurate, I would say, or actual way it is being implemented. But it's just easier for us to look at them from the layered perspective of OSI. So layer 2, you have Ethernet, PPP, and all that. You have layer 3, you have IP related protocols, V4, V6, ICMP. Layer 4, you have your TCP and UDP, NFS for layer 5, and a whole lot of others in layer 7, HTTP, FTP, IMAP, Telnet, DNS, and a lot of other things that I actually don't have time to write down there. So what I really want you to see is this. Notice that there are different possible attacks, okay, if you look at these different layers, which kind of supports what I've been saying just before this. We said that you have to provide protection in all layers, because if you only look at one layer, you can still be attacked. They can still use the weaknesses of all the other protocols in lower layers, okay, to send you those types of attacks. So on layer 2, you have ARP spoofing. So low-level types of attacks, spoofing, map flooding, okay, which is an attack to which goal? That's an attack to availability. Okay, it's also an attack to the integrity. Are you actually talking to the correct machines? Are you exchanging data or packets to those machines? Or maybe you're talking to someone else. Okay, ICMP flooding, ping floods are examples of attacks to availability. TCP attacks, routing attacks, SYN flooding is probably more on the a little bit of the integrity, a little bit of confidentiality. And on layer 7, we have all sorts there for all types of applications: DNS poisoning, phishing, SQL injection, scamming, spamming, and a whole lot more. So it's kind of scary to look at this, because in most of us, like, we have different roles. Some are network engineers, some are application engineers. We only have a tendency to look at securing our realm. But to be able to provide full security, we have to involve a lot of others, right? That's why sometimes you might need a security professional that really just looks into the security of your entire infrastructure. Now, let's just have a look at some of these common attacks, okay? Now, the first one, let's start at the very bottom, is TCP attacks. So what is this? A TCP attack is kind of an exploit to the TCP protocol. TCP uses what we call as a three-way handshake. It's a connection-oriented protocol. So it must first establish a connection with the other party before sending the actual data. And it's done using by sending SYN, SYN-ACK, and acknowledgement messages. So most of the setup that we have is like client-server architecture, right? So if a client connects to the service to get some service from that, so the client sends a SYN request, server replies with a SYN-ACK, and the client finishes the three-way handshake with a final acknowledgement. Very simple, very easy. Now, what happens in a TCP attack is you have an attacker, and this is an attack to the availability, right? Because he will then be sending a lot of SYN requests, expecting an acknowledgement from all of those SYN requests going to the same machine, going to the same attacker, but there is no final acknowledgement being sent back. So the problem there is, what if there are legitimate users? Okay, if I am doing a DOS attack, denial of service attack, okay, this is actually an example of that. Because if I have a legitimate user that user will probably see, if it's a web server, will probably see a website that is just timing out. Okay, then he won't be able to do or find the information that he needed from that server. Okay, so that's a problem. Another, let's look at DNS cache poisoning, and this is happening on the application layer. So everybody probably knows how DNS works. So you have a client who wants to find out the IP address given the domain name, okay, so that he can send the packets with the correct destination. So the client goes to a DNS server. That DNS server goes to a process of sending that data through a DNS hierarchy from the root until it finds the authoritative server. So that authoritative server will reply back, this is the answer that you're looking for, the IP address for your domain is this, and then gives it back to the server that requested for it, and then gives it back to the client. Client now connects to the correct server. Okay, it's okay, we're just starting. You can still catch up. We're just basically looking at the different examples of common attacks. So we're looking here at the application layer, which is the very good example, which has been happening a lot, is DNS cache poisoning, right? So here, so we said that's how DNS works. But what if you have someone, okay, an attacker who pretends to be that server and will also reply back to poison your cache? So he'll reply, he'll send a lot of replies there, hoping that one of them will be accepted. And how? All queries that are coming up from your caching server or recursive server has a particular query ID, QID, you can see it there, so that it can match the replies to that query ID. Now, if I have an attacker, he will send a lot, okay, within the range, expecting that one of them will be accepted. And this is a targeted attack, okay? He would sit very closely, maybe just a few hops from this caching server, so that his reply will come before the actual reply. So what's the problem here? There's no way to authenticate that the data that I receive as a DNS server is coming from the right source. So what's the problem there? Integrity, right? I'm not sure whether this is the correct authoritative naming server. Therefore, the data that they give me, I'll just accept it. I assume that it's coming from him. But what if it's not? But what if it's coming from this attacker over here, right? Since it came early, it matches the query ID. I will accept it, forward it to my client. My client is now connecting to a dodgy web server. Maybe this web server pretends to look like your bank website. Okay, so it kind of fools your client to log in with his credentials, with his username perhaps, with his credit card, his password, and then that information is being gathered by the attacker. Okay, it's scary because a lot of users don't actually have a way, or well, don't check, and a lot of ordinary users fail to add that extra checking of whether they're connecting to the right or the correct servers. So that's DNS cache poisoning. It's been used a lot. Um, in around 2005, there's actually a lot of issues about this. So the result was many people started implementing DNSSEC. We'll look at that in a bit later on. But that's a problem. There are lots of different types of attacks and many different names for that, but it usually would be summed up to this. Okay, it would usually start with reconnaissance attack. Okay, an attacker. Okay, it can be different types of attacks. You know, someone that's targeting your network, because the question that you have to answer is, who is your enemy? And there's a lot of answers to that. It can actually be anyone. If it's a targeted attack, then it can be from a competitor, or it can also just be from a newbie, or um, maybe someone who's just like trying his luck out, wanted to implement something, and you happen to have some vulnerabilities, so you became his target. Okay, so it usually starts with reconnaissance. Someone, an attacker, would find possible vulnerabilities. There are many tools that you can use. You can just simply just download um, some applications, click on a few buttons, and then try to do a ping sweep or a port scan. So the level of understanding or knowledge of these attackers actually vary. Okay, okay, some would just like download these tools and then try these. Some have more knowledge and they will create their own scripts, so it's more of a targeted attack to you. Okay, and then what can they do? Once they found out vulnerabilities, they will exploit that vulnerability. Okay, it can be via sniffing, it can be a passive, it can be active. Man in the middle attack is considered as an active attack. Okay, they're actually intercepting message intended for valid devices, either don't send it through to them or alter that data. So again, this is about integrity of the data that you're receiving. Do you actually make sure that you are receiving correct information? What do you do with that? Okay, we also have spoofing, hijacking, and one of the most common attacks that are targeted towards availability is DOS, or right now, more prominently, distributed DOS attacks. Okay, so there's many, and usually it's not just one off, like one type of attack. It usually starts with one and then progresses to another. Maybe they will also send one type of attack to distract you so that they can use that to exploit one other vulnerability to get into your system. That's how smart they are. So what do you do? What can you do? As I said, first is to be able to identify your weaknesses. What are the problems, okay? What are the possible vulnerabilities in your network? Okay, someone has raised his hand. Can you please type your question if you have any on the chat panel? Otherwise, I'll be transferring the audio to you, and that means you'll have to speak on the microphone. So we're not going to do that. All right, so if you have questions, if you have anything to add, can you please write them down in chat? Okay, I can see you typing now, so I'll just let you go through it. But like, let me just continue with this while he's typing something. Oh, can you kindly explain what is ping sweeps? It's simple. It's you have a simple script, a simple program that will you have a list of a range of IP addresses, and you'll try them one by one. So it's more of is anything, any device reachable. Okay, I will ping this IP address, see if there is any device on the other end. And if there is any, I'll do a port scan, see whether there are ports that are open that I can get in. So you can easily create a script that can do this, or there are lots of applications that do this in conjunction with other types of attacks. Because this is one of the easiest, right? You're basically looking for possible targets. Script kiddies, newbies would tend to do this. More like this is not like what targeted attacks would do. It's more like script kiddies because they want to find out devices that are open for them to attack. Okay, what is the major difference between the man-in-the-middle attack and a spoofing attack? So man-in-the-middle attack, well, spoofing can be part of, can be an example of man-in-the-middle in some ways, but to point at the main difference with them is like when you're talking about man-in-the-middle or monkey-in-the-middle attack, as many people would call it, it's you have two devices, source destination. They keep on talking with each other, so they have no idea that there is another device sitting somewhere in the middle and intercepting with the data. So it's a bit like A and B, if they're talking. A is sending messages to B, but he's actually not very sure that he's already talking to um, let's say the attacker in somewhere in the middle. So in that sense, it's kind of you see how it can easily become like spoofing, right? But the thing is, the destination is still the other party, and the man sitting in the middle might most likely will still forward that to the other party, but a modified version of that, an intercepted version of that. So that's how it works. Sometimes it's even just like they're not doing anything with those packets. They're just holding it for few seconds before forwarding it through. But with spoofing, think more of devices that are acting more like, say, if you are in a cafe and you want to connect to a Wi-Fi, a wireless access point somewhere. Somebody can pretend to be that cafe's access point, use the same SSID, and people are fooled to connect to that. That's a very easy example of spoofing. So there's some overlaps with man in the middle and spoofing, but that's the main difference for them. I hope that answers your questions, Urpan. All right, so any others? I like that you guys are um, interacting. Keep it coming. When I see them, I'll try to answer them as soon as I can. So let's go to this other one. Okay, so let me just see. Someone wants to come into the class. All right. So as I said, I've only shown you a few examples. Of course, there are many others. There are many ways that each of these attacks can be used together, okay, to send you a bigger and more um, distractive form of attack. So what do you do? Okay, what can you do? Of course, you'll have options to implement security protocols. But looking at the big picture, you can do it in two ways. The the standard way that we do things, even up to this day, is defensive rather than offensive, right? So we put defenses all around our network perimeter. And we do that using firewalls and intrusion detection system, intrusion prevention system, IDS, IPS. Firewall would usually be your first line of defense. You might have a box that is acting just as a firewall, or maybe it has a lot of other functions as well, such as NATing or routing capabilities and all that. But that's your firewall. Okay, you set up ACLs, which type of traffic are allowed in, are they allowed to SSH into your network, are they allowed to access certain services, certain ports? You set that up on your firewall. With IDS, if there are patterns of possible infringements or access into your network that is kind of abnormal, okay, it is able to detect that by looking at a list of possible patterns and then warn you or send message, send email, send SMS to your administrators of a possible breach. So that's your IDS. IPS is more, I guess, more active in that sense that it doesn't just detect, but when this happens, there is a trigger and it will implement something. Okay, that's your IPS. But that's the standard way of how we do it. Okay, it's more defensive. But the problem with this is, what if we do everything to add security on our perimeter, but in some way or the other, okay, the attacker was able to get into a computer, a laptop, or a user account somewhere inside that network. And everything from that point forward will be attacked from inside, right? So aside from that defensive-oriented technologies that you see there on top, we must also add more onto this. One way is to build trust on the TCP/IP infrastructure. With trust, we mean there has to be a way to control access to certain services. There must be an authentication mechanism, or you can also implement PKI using digital certificates, okay, to provide protection to certain services. Now, just go to the next slide. So we're talking mostly about access control in this case. Who are allowed inside our network? Who can get into our systems? And once they're in the system, what can they do? Right? So very simple concept of AAA here. Authentication, authorization, and accountability. So we all must have, okay, a way to do this. Maybe you have an authentication mechanism, a AAA server, right? And all access to all your network equipment will be going via that authentication mechanism, and everything, all the transactions that they do while in their system is being recorded. That's what we mean here by AAA. Who can log in? Who are allowed to log in? You should have different roles in the organization, each of which will have its I know some of the services are available to them, some other services are not available, right? So authentication is the part where you have that system in place where they can identify themselves and you can say whether they can log in to the system. Once they're there, what are they authorized to do? What is their role? Can they change this? Can they delete this? Can they make or commit these changes? That's authorization. And then for accountability, whatever they do while in the system, maybe they run this command, maybe they run a script, maybe they deleted the file. Simple as that. Maybe they stopped and restarted the process. So that is all recorded. There should be no way. We call this, the term for this is non-repudiation. There has to be no way for them to deny that they did this because you have proof. It's in the system. That is accountability. Okay? So that's kind of a very simplistic concept, but an important one when it comes to adding confidentiality to the services and to your data. Another important one is cryptography. Okay, so crypto, I'm not going to go to the details of what crypto is and all that, and how do we implement this, what are the mathematical functions involved with this, but let's just make it very simple. Cryptography is a very important concept in security, okay, especially with information security. Here we're talking about encryption, where you can encrypt your messages, your data, whatever it is you're sending out there. Okay? And then even though someone is sniffing, someone is listening on what's going on the wire, they will only see gibberish uh, data, garbage, right? But once it's received on the other side, there is a way to reformulate that to come up with the same message, okay? That is the same as the one that they sent. So that is encryption. You transform a plain text into something that is undecipherable using some algorithm and using some key so that it can be sent through and you're confident enough that nobody will be able to read through it, okay, even if it's on transit. Now we have two main types here. We have symmetric key algorithm, you can see that here, and also asymmetric key algorithm or cryptography. So symmetric uses one key. So how does this actually happen? So in cryptography, I might have some diagrams here. You can see that there. You have a message, you have plain text, whatever it is that you want to protect. Here, our focus is what? Which goal? Confidentiality, right? You there's another thing that you can protect here, which is integrity, which I will explain in a little bit. But mostly, this is about confidentiality. So if your message goes through some kind of algorithm, and then you have a ciphertext. This is sent through the wires. Once it's received by your recipient, the destination, it will be decrypted so that you get a plain text. Simple concept. Now, to be able to do that, to come up with a ciphertext, it's a function of two things. Of course, you need your original message, you need an algorithm, you need a key. So encryption is very reliant on the key. The algorithm, of course, should be strong enough. There are many algorithms. It has evolved over the past. As soon as you find weaknesses in the old, there are like moves from the crypto community to come up with new standards. But from a user's perspective, the algorithm is there. It's out there. It's public. It's available. You know how it works. You know how it uses XOR. You know how it formulates your plain text into blocks before it is acted upon using that algorithm, right? So the algorithm is public. So to protect your data, you need to protect one thing, your key. You select a good algorithm, but the key should be protected at all times. So there are two types, as I've said in the previous slide here. You have symmetric and asymmetric cryptography, right? So if you're encrypting and decrypting using the same key, that's symmetric key algorithm. If, however, you are using asymmetric key algorithm, this encryption key and this decryption key here are different. So you have key pairs. So again, with symmetric key algorithm, examples there are DES, triple DES, AES, ID, RC5. I don't think we'll have time to go through each one here, but the current standard is AES. This is also called as private key cryptography because of that same reason. You want your key to be kept safe or private at all times. You don't just share it around. However, for this to work, the other party should know about that key, right? So you share that key, but this is done out of band, meaning it's not part of the algorithm itself. You have to either meet face to face, hand over the key, maybe send it via a secure protocol, via SCP and things like that. But that's how you share it. So you have to be very careful who you share that shared secret. Another one, the other category is asymmetric key cryptography. Now for this, we will be using key pairs. This is also called public key cryptography. It doesn't mean that you're just sharing all of your key, right? But there are two parts to it. You have a public part and a private key part. You can generate the public, it is generated at the same time using algorithms, right? But if someone has a copy of your public key, there is no way for him to kind of reverse engineer it to come up with the private key. So you can rest assured that it is impossible. So what do you do with that? You share, okay? You share the public key to everyone. Maybe you upload it to your website, attach it to your emails every time that you send it out. Maybe you are uploading it to a key server, okay? A key ring. There's like lots of them on the internet. But the private key part should always, of course, be kept as a private. So again, as I said, if you're talking about confidentiality here, which type of key will you be using? So here, you'll be using the recipient's public and private keys, right? Obviously, you don't have a copy of his private key. Only he has a copy of that. But you know his public key. You can get that. It's supposed to be public. You should be publishing that. So you can get that public key, send that message across to the other party, and then when he receives it, he will now use his private key to decrypt the message. Okay, so that's how it works. But another part of this is for integrity. How do you protect integrity? So in that sense, when you talk about integrity here, you want to make sure that when you receive a message, it's coming from the right source, right? That's what we mean by integrity. So in that case, you'll be using your own private key, send it across. You're not exactly concerned with the confidentiality of your data, okay? You're not exactly concerned with I don't know if anyone is able to read your message or intercept your message. But your main goal is to make sure that in the recipient side, they know they can verify that it's coming from you. So in that sense, you use your public key, your own public key, your own private key, and then send it across. In the destination side, they will use your public key to decrypt the message. So two ways that you can use asymmetric key cryptography for this. But you can see this very well. Cryptography is very important. And it's not just about like our messages, right? If you look at security protocols, I might have some examples later on, but if you look at different security protocols, such as implementations of, say, SSL, TLS, or even PGP, or let's say even if you're implementing things like IPSec, if you know how they operate, okay, you'll see how they are using cryptography. The thing is, you don't just choose whether to use symmetric or asymmetric. There are pros and cons to each. Sometimes it will be easier to use symmetric cryptography. In other scenarios, it might be better, safer, easier for you to use asymmetric cryptography. By the way, symmetric, of course, generally would be faster than asymmetric cryptography. But you have to like weigh on those pros and cons between them. But thing is, if you look at how it is implemented in the security protocols, they're actually using both. Sometimes, like at some stage in the process of negotiation, they will use asymmetric key cryptography, and then after that, they will use symmetric key cryptography. You see the problem with symmetric key cryptography, right? It's a minor problem, but when you're dealing with a lot of keys, it can be problematic. The issue there is, how do you now share the key? Okay, how do you share that private key in an easy or more organized way? Okay, and still keeping it secure. And one way is to use asymmetric key cryptography. And once you have already done that, then all transactions between your two endpoints will now be using symmetric key cryptography. So in that sense, we can use both. All right, so I hope that makes sense to everyone. Now, another thing is PKI, Public Key Infrastructure. MD5, so it's not here, right? So asymmetric cryptography, the current standard is actually DSS or DSA, Digital Security Standard, if you look at it from FIPS documents. But a lot of people are still using RSA. Now, MD5 is a hashing algorithm, okay? It's a hashing algorithm. In some way, it uses crypt, but it's a one-way hash. I'm not sure if I have some slides over there, but you have different types, right? So this is what we call as message digest or hashing. A message digest is kind of a fingerprint to a message. It is useful because you can verify that you have the correct data. So what they do, when they usually use this, so it's not just MD5. Other examples are secure hash algorithm or SHA-1, SHA-2. And you use this when, say for example, you're downloading, I know some of you are doing this perhaps like when you download a distribution, maybe a Linux distribution or any application, download it, and then how do you know it's correct? How do you know it's not corrupted? How do you know it's the correct distribution, right? It's the correct file. Now, most of the publishers of these will also publish an equivalent fingerprint of that application. So what you do on your end is do an MD5 hash or a SHA-1 sum, and then compare whether what you came up with is the same as the one that is published by the the website. Okay, so that's what we call as message digest or hashing. It's a bit different than using these keys for encryption, okay, symmetric and asymmetric, but it is also one of the useful. It has it's useful as an application, even used with say things like digital signature, which uses both cryptography and hashing. Does that clarify everything to you? So let me just double check if I have some examples here. Probably not, but that's pretty much how it works. You can use it in a lot of ways. Um, like systems administrators would definitely it's recommended not to save passwords in plain text format in databases. Instead, it should be the hash value of those passwords. So when you have someone logging in and then it will check with the database, they're actually not checking if it's the correct password, but is the hash of this password the same as the hash that is saved on my database? So that's another example of where you can use it. As I've said, digital signature is one of them. With digital signature, it's about integrity, right? Because you're signing a document. That's one way that hopefully most of you will start using if you're not doing it yet, is to sign your outgoing messages. Okay, there are many ways to implement that. You can use SMIME, you can use PGP. So when you sign your document, if someone received it, okay, they can verify that. Now with digital signature, okay, it uses public and private key pairs. It also uses hashing because what they will do is come up with a fingerprint of your email, of your message. So it doesn't really matter if your original message is tiny or very long, the output will always be the same size. Okay, that's why it's like a fingerprint of that. So so he sends that, create the signature, sends that across to the other party to verify it. That's how we use what they call it, message digest with digital signature. All right. So I hope that's clear. Another, as I've said, is PKI, or public key infrastructure. How many of us here are using digital certificates? I would say a lot of us. Okay. Maybe not for say websites or services that they deem are not really that important to have, say, a way of verifying who is the publisher of it. But it is important, right? How do you know that you are connected to your your bank? Okay, you can check the certificate. You check if the certificate is valid, check if it's published by a trusted certificate authority. Okay, and it also uses that digital certificate to secure the communications using HTTPS. Okay, now with PKI, there are different components to this. You have your CA, which is a third party. That CA can be just one, or it can have a separate registration authority. That CA essentially, you would go to them, tell them that I want this, I want to have this digital certificate. Can you create one for me? They will sign it, and then you can use it later on, right? Now, there's another way of doing something very similar. Now this one is more kind of, you're following a rigid hierarchy. You have certain certificate authorities, but it can also be done in, say, a more informal way. Okay, maybe not. It's not called PKI, but like if you want to implement something called PGP, okay, pretty good privacy, then you can encrypt your emails, or you can sign your emails. You can use PGP. Now that one doesn't use the PKI infrastructure, but it's more reliant on other people signing your certificates for you, not the CA. So there are two main streams of doing this. PKI is obviously if you want digital certificates for your services, then you can do this. With that one, if you wanted to save or encrypt your messages, and you don't have a way to use digital certificates, then this is another way. Okay, so where are we now? So you've already seen this, right? These are the attacks. I've already told you that to be able to completely protect your system, and even with all of the security measures, you're not actually 100% secure. It's never possible. You should accept a certain level of risk. Now, you've seen all of these attacks, but there's a way to add protection on it. Okay, protocols have been made available for it. You have PPP, PPTP, you have IPSec, you have TLS, SSL, and you have things like HTTPS, DNSSEC, and PGP on the upper layers. So these are security protocols that have been added later on, have been standardized later on, that can add some form of security in your implementations. So how many of you are using IPSec? How many of us in this room are using TLS? Okay, these standards have been there for a while, and they protect certain parts of our network. So it is essential for us to use them. I'll just go through one, okay, IPSec. IPSec is an example or a standard of VPN. Now talk about VPN, what are we doing? We're protecting our data, okay, as it goes through the internet. So it's kind of a replacement to leased lines where you have the dedicated line between, say, different remote offices for the same organization. So instead of using those dedicated lines, why not use the internet, right? It's public, it's free, it's huge, and all of those remote offices will be using the internet. So you're not relying on a dedicated line. But it's public, so you want to add some protection. You want to keep your data still confidential. So we implement VPN. There are two types, two main things we use VPN. One is that example that I just gave you, that's site-to-site VPN, and the other is remote access VPNs. So again, I think the question here is, how many of us are using VPN when we are in a network that is we're not sure, or we're not sure if we can trust that. Maybe we're sitting in a cafe, maybe you're sitting in an airport, and you need to connect or send. Basically, you need to use the internet. How sure are you that um, those connections are secure? So what you can do and what you should be doing is connect via VPN to somewhere that you trust. You're using that link, okay? Set up a tunnel into it so that all your traffic goes to the network that you trust. So that's remote access VPNs. And there are different protocols that have been implemented all throughout it. PPTP, L2F, L2TP, those are all in the layer 2. Now, IPSec is another VPN standard. And the difference between IPSec compared to these other three is that it operates on the network layer. So this is mostly for network engineers, security professionals to implement on the network layer. It is a good implementation because it is independent of the applications that are working on top of this network infrastructure. Okay, so this is where it works. You have applications. If someone on the source side wants to send, say, SSL connections, set up SSL connections to the destination, that's independent because you set up everything in the network layer or your layer 3. Okay, what's IPsec? IPsec provides layer 3 security. There are two modes to implement this, tunnel mode and transport mode. There are different components to IPsec, security components, the ways that are used to interact with the other endpoint, how do they establish that tunnel and all that. So those components are your AH, ESP, IKE or Internet Key Exchange, and all of these uses what we call SSA or security associations. Obviously, we won't have time to go through the details of the IPsec operations. So here I just gave you a very brief overview of what it is, why it can be used, and hopefully, if you are able to, you can implement something like this. Now, there's a bit of a problem with IPsec. There's two versions of IKE, IKE version 1 and IKE version 2. Most of the devices that you probably will have support for IKE version 1. Okay, and if you look at the standards, the RFC Suite IKE version 1, it's a bit difficult to understand. So different vendors actually have different implementations. That's where most engineers have a hard time implementing IPsec, and so they choose not to use IPsec VPNs, would rather go for, say, SSL VPNs. So there are many ways to implement VPN, of course. This is one of them. Okay, so if you can, give this one a try. Now, the other one is protection in the upper layer. Okay, we have your TLS. Okay, transport layer security. If you are aware, I think that was like April of last year. They found problems with an implementation of TLS, OpenSSL, and later on in the year, they found an issue, a bug in the old version of uh, the protocol, which is SSL version 3. Now, the thing with that is um, we now have TLS. So the progression is you have SSL version 1, SSL version 2, SSL version 3. SSL version 3 is the basis of TLS. TLS, or Transport Layer Security, is the current standard. You know, this is an important security protocol. It's used by a lot of application layer protocols, right? Most notable of which is your HTTP. HTTP, if you want to say provide a secure version of that, we use HTTPS, okay, and that relies on TLS. So I think with you, one thing is, of course, if you have sites that you always come to, make sure that you access them via HTTPS. If you are providing this service, okay, if you're providing login to your customers, for example, make sure that it uses TLS, okay. Now, if you have support for SSL version 3, okay, there are, say, sites where you can check whether it's still like defaulting back to SSL version 3 if customers are using that, but you should remove that, okay, and yeah, don't use that version anymore, which is vulnerable. All right, so just a few examples of how we have actually added security mechanisms or security protocols on top of what we already have, like what the TCP/IP protocol stack. So hopefully that gave you some idea of which parts of my network I need to look into, which parts needs protection, and looking back at the goals, what kind of protection should I implement? There are many tools that it can implement um, those protocols. So it will be now up to you to look for the best ones that suit your needs. And now just to wrap this up, I have here security management. So security, although we looked at the very, I would say, um, big overview of security from a network point of view in this session, security is a whole lot more. Okay, security is not just about protocols. It's not just about the tools that you implement. It's largely about people and largely about the policies and rules. Okay, so there's a big part that you have to deal with creating policies for your organization, setting up standards based on those policies. Policies normally change. It's more something that you create and then you visit maybe every couple of years. But if there are changes with how things are implemented, the size of the keys, what is the best protocol, we don't normally put that in the policies. Instead, that is added into the standard. Things like what will be my standard key size or password length will be on your standards. And you also have guidelines. Guidelines is more of what you tell to your users, guidelines for how they would help out with security by doing these things. All right, so you should have a look at those. You must develop a comprehensive security policy. Do you have that? Okay, do you have a usage policies, for example? What is the minimum password length for your users? How often are they supposed to change passwords? What do you do if you have users or user accounts that for, let's say, staff that have long been gone from your organization? Do you have a policy that looks at automatic creation, deletion of those user accounts? What is the encryption mechanism that you use for your organization? Which are the standards that you adhere to, right? Do you encrypt data on your user machines or end user devices? Or do you encrypt messages as it is being passed around in your network? Okay, are you encrypting all of your communications? Are you using public key infrastructure? Are you using digital certificates? Things like that. It's just like a few of maybe a very long list of things that you might have to look into. But at the end of the day, okay, as I've said at the beginning, okay, you're not 100% sure that you can protect your system, you can protect your network. There is always that chance that you will be subjected to an attack. You can only secure your system to some extent and accept some form of, say, risk. What is your, um, say, what level of risk are you willing to accept? Will you lose data if that happens? And if you lose data, if you're attacked, what is the implication of that to your organization? Okay, so sometimes you have to weigh about risks and costs, implementation issues, and all that. Now, but yet at the end of the day, there's still that possibility that you will be attacked, right? So what do you do if that happens? Do you have an attack mitigation plan? Okay, if it's an attack to a service, how do you make sure that you make that available outright? Do you have a backup? Can you recover from that backup quickly? And how quickly can you do that? Okay, if say um, um, the attack has passed, what do you do after that? Okay, how do you check or add more security measures so that that attack won't happen again? So disaster recovery and attack mitigation plan plays a huge part in your bigger security management plan. Also, do you have a, say, something like CSIRT or security incident response team in your organization. It doesn't have to be big. Sometimes it's the security engineer. Sometimes it's a network or systems engineers together. It can be just a few people, but something that you can pinpoint that will be part of your team, so that when something like a disaster or an attack happens, you know who to reach. You have a plan of action on how to mitigate that problem. Okay, so I hope that you got something out of this. That I think is the last part. Oh, I have also have the APNIC quiz database. As you know, um, APNIC publishes or has this public repository of all the internet resources, IP addresses, AS numbers, with information about who should be handling, who's responsible for that resource. So this is used a lot um, by most of us. Okay, so it's a good resource if you're being attacked, you want to find out, or maybe you get a lot of spam coming from the same IP address. What do you do next? Find out where the source is coming from. Who's responsible for this? So in that manner, you can check with the WHOIS database. So that is apnic.net/WHOIS, or you can also use the WHOIS utility on your command lines. From there, you'll find that information. You can communicate with them in order to resolve the issue. Maybe they're also victims, and so they will know that um, their IP address block is being used for attack, right? So again, coordination with all other engineers in the community. All right, so that's it. That's the last section of this presentation. If you have any questions, can you please write that down? Otherwise, you also have the link here to the feedback form. I was told earlier that you are able to click on this, so I won't write down the link on the chat panel anymore. If you have a few minutes, few seconds actually, can you please try to fill this in? This is very important to us. Another is the link to the materials. If you want a copy of this material, you want to review it later on, you can, of course, do that. Send it to this link. Um, go to this link. You can see the PDF files of this. Is HTTPS really secure? That is a very controversial question. There have been a lot of discussions about HTTPS being secure or not. Thing is, it relies heavily on TLS, and TLS has been in a lot of um, there are a lot of effort to attack or to find vulnerabilities in TLS. You've seen one of that, right? You've seen a problem with the implementation of that with OpenSSL last year, which made more than half of the internet vulnerable. We've seen how the protocol vulnerability was found later in the year with SSL version 3. So I would say it's still one of your good options, but there might be some level of risk. There might be vulnerabilities. This has never been found yet. Okay, but right now I would say it is. Okay, that's of course my opinion or my take on it. You'll see possibly a lot more discussion if you read through the internet. But as I've said, you have to accept some level of risk. And one thing that you can do as well is not just implement this, but implement a whole lot of other security protocols that we have discussed. So it's a combination of those things that would make you or your data and your network more secure, I would say. All right. So I do hope that answers your question in a way, Orpan. That's my take on that question. If you have any others, please write them down in the chat. I'll be happy to discuss anything with you. If not, I've already given you the link to the handouts. If you have questions when it comes to the APNIC quiz database, which I've discussed very briefly, please have a discussion with us, or our help desk team will be able to help you out as well. All right, so I guess we will end there. Thank you very much. Okay, again, if you have more questions with me, you have a copy of the slides. You can download it. You have there the link to my email address. It's actually cheryl@apnic.net. So you can send me an email anytime, and I'll try my best to answer them or give you a good conversation via email, and we can discuss them. Okay? Thank you very much again. I'm very happy that we have a lot of people in this. Security is a major issue these days. So when you can, okay, please make sure that if you're the person responsible for parts of your network or for your entire network, okay, look at them, find out the vulnerabilities, find out the issues, and based on your level of risk, implement um, implement the protocols, add some security there that can protect your system. Again, it can start very basic. Things like using PGP, for example, to sign or encrypt your emails, right? It's very easy. That's open source. You can download that. It's very easy to install. And yeah, sorry, I keep on going and going, but I think we will end there. Thank you very much. I can see all your information in the chat. My email is Cheryl, Sheryl, at apnic.net. If you want to send me an email or questions, please feel free to do so. Okay, so again, thank you, and I hope to see you guys another time. Bye-bye.